Take a look at this. Ice floating on water. It seems completely normal, but scientifically, it's actually very strange. Most substances become denser when they freeze. That means their solid form sinks in their liquid form. But water does the exact opposite. So why does ice float? To understand this, we have to zoom in, way in, to the molecular level. Water is made of tiny molecules called H2O. Each molecule has one oxygen atom and two hydrogen atoms. In liquid water, these molecules move around freely. They slide past each other, constantly forming and breaking weak connections called hydrogen bonds. They're close together, but not perfectly arranged. As water cools, the molecules slow down. When the temperature reaches 0 degrees Celsius, 32 Fahrenheit, something fascinating happens. Instead of packing tightly together like most substances do when they freeze, water molecules begin forming a rigid, organized structure. They lock into a beautiful hexagonal pattern, a repeating six-sided shape. This structure actually holds the molecules slightly farther apart than they were in liquid form. That extra space makes all the difference. Because the molecules in ice are more spread out, ice takes up more space than the same amount of liquid water. And when something takes up more space without gaining mass, its density decreases. Lower density means it floats. That's why ice cubes float in your drink. Ice is about 9% less dense than liquid water. And this unusual property isn't just interesting, it's essential for life on Earth. When lakes freeze in winter, the ice forms on the surface and floats. This creates an insulating layer that protects the water below from freezing solid. Fish and other aquatic life can survive beneath the ice because the water underneath remains liquid. If ice sank instead of floating, lakes and oceans could freeze from the bottom up, dramatically changing life on our planet. Water is one of the very few substances where the solid form is less dense than the liquid form. That makes it scientifically unique and incredibly important. So the next time you see ice floating in a drink, remember, it's not just a simple everyday phenomenon. It's the result of a beautiful molecular structure and one of the reasons life on Earth can exist as we know it. Science is everywhere, even in a glass of water.